Here's a couple of examples to do with the equations of lines with parallel and perpendicular lines. So let's have a look at the first one. We've got 2 points A and B and we're told their coordinates. Now, in addition to the question, I've sketched out what they look like. So 0, 1 and 2, 4. And we're asked to work out the equation of the line AB. So let's draw in the line. So to find the equation of the line, we know it's going to be in the form y equals mx plus c. And so what we need to find out is the gradient and the y-intercept. Then put those values in and we've got our equation. So first of all, what's our gradient? So our gradient, or m, can use this formula. So y2 and y1, x2 and x1. So that's 3 over 2. We can leave that as an improper fraction if we want to, or turn it into a decimal, 1.5. But we've got our value for the gradient. Second, we need to know the y-intercept c. Now it helps us that we've been given the value of a point on the y-axis, 0, 1. So if it goes through 0, 1, then the y-intercept is 1. So we've got our two values, m and c, so you can write out the equation y equals m times x plus c. That's our equation of the line. Right, part B. Now we want a line parallel to AB. We want its equation, but it's got to go through this point. Now if it's parallel to AB, that means that the gradient is exactly the same. So we don't need to work anything new out there. That's our gradient. Again, we need the gradient and the y-intercept. And again, on this question, we've been told a point that it goes through which is on the y-axis. And it's the point on the y-axis that is the y-intercept. And so our value of y when it passes through the axis is 5. So we've got our m and our c, which is what we need. So y equals mx plus c, y equals 3 over 2x plus 5. And that's our answer to part B. Right, how about C? Write down the equation of a line perpendicular to AB. So we know that for a perpendicular, the equation is the negative reciprocal. So if m1 is 3 over 2, we know if we multiply them together we get minus 1. But that means that the second gradient is going to be the negative reciprocal. So we swap them upside down, it becomes 2/3, and then the negative of that. Now, if the line is perpendicular to AB, it just means that at right angles. It doesn't tell us where. So if we've got the gradient right, then the y-intercept, it could be a lot of different values. It could be any value. And so we're not too worried about that. So if it's perpendicular to AB, we just need to make sure that the m is right. And we can leave it at that. That's a line perpendicular to AB. Right, part D. The equation of a line perpendicular and passing through this point. So if it's perpendicular, we've got our gradient already. And if it passes through this point here, well, once again they've given us a point which is on the y-axis. So it crosses through the y-axis when y is 2. So we've got our values for m and c, so y equals m times x plus c. That's the end of our first example. Our second example is a bit shorter. Again, equation of a line, and this time note that it's perpendicular. So the gradient of this original line, we've got the gradient there, it's got a gradient of half. So we know the product of perpendicular gradients is -1, and so we need the reciprocal of a half. So we turn it upside down, it's 2 over 1 or just 2. And it's the negative reciprocal, so that will become -2. We've got a point on the line, 0, 5, so on the y-axis it goes through 5. So the equation of our line and there it is.